1 and adding 0, 2 times 1 and adding 0, and 2 times 1. Negative 2 plus 2 would be 0. And again, a remainder of 0 means this is a factor or 0 of the question. So positive 1 also works as a 0. And again, to continue the question, looking back at our positive zeros, we have 1/2 and 1 over 1. Keep in mind they also could be negative, so we'll check negative 1/2 and negative 1. And again, each time you get a remainder of 0, we can use the other numbers left over as the function to see if the other zeros divide into that also. So the next number we'll check, instead of 1/2, we can check the negative numbers, which would be negative 1/2. And again, if we have a 0 for remainder, that means negative 1/2 is a 0 or a factor. If we get any other number besides 0, it means negative 1/2 does not work for the function. Dropping the first number down, we'll have 2. Each number will multiply by negative 1/2 this time. Negative 1/2 times 2 would be negative 1. 2 plus a negative 1 would be 1. Negative 1/2 times 1 would be negative 1/2. 2 plus a negative 1/2 would be 1 and 1/2, or you can write it as 3 halves. Negative 1/2 times 3 over 2 would be negative 3 over 4. And 2 plus a negative 3 over 4 would be 1 and 1/4, or 5/4. And again, if this was a 0 remainder, that would be negative 1/2 is a 0 for the function. Since we have a remainder, a number that's not 0, that means negative 1/2 is not a 0 and does not work for the function. And the last possible 0 that we'll check is negative 1. Again, for this question, we can use the last answer that we had with the remainder 0. So the 4 2's we can bring down and see if negative 1 divides into it. We cannot use the numbers listed above since the remainder was not 0. And again, for this question, the last possible 0 that we have, if we have no remainder, this would be a 0. If we have any other number that's not 0, then negative 1 does not work. Dropping the 2 down, negative 1 will multiply for each number. Negative 2. 2 plus a negative 2 would be 0. Multiplying by negative 1 would still be 0. Adding will be 2. And negative 1 times 2 would be negative 2. Adding will get a remainder of 0. Again, if we have a remainder of 0, that means negative 1 is a 0 for the function. Since we went through all the possible zeros, 1/2, 1, negative 1/2, and negative 1, the 3 that worked was 1/2, 1, and negative 1. So for this function, we have 3 rational zeros. Those zeros would be 1/2, 1, and negative 1. We did have a degree totaling of 5. So since we found 3 zeros, the other 2 left over would be imaginary zeros. But these are the 3 rational zeros for the function. Title of the last section today is Find All of the Zeros. In this section, we'll continue to use long division to go through the possible zeros, but we'll find all these zeros, which include the rational zeros, but also imaginary zeros, if there's imaginary zeros for the function. First question is f of x equals x cubed plus 3x squared minus 25x plus 21. Looking at the function, since it's x cubed means there will be 3 zeros for the function. All 3 of these could be rational zeros, which will be the p's and q's, or we could also have imaginary zeros. Again, to start the question, we'll list out the possible zeros and use long division to see if we can find the possible rational zeros. The last number in this case, P, is 21. The factors of 21 would be 7, 3, and 1. And Q, which is the first number, would be 1. If we list out the possible rational zeros, which could be positive or negative, each of these will be divided by 1, which would stay the same. So we'll have 21, 7, 3, and 1. And we'll also have negative 21, negative 7, negative 3, and negative 1. So there's 8 possible rational zeros. We'll go through and see which one of these are actually zeros. Again, picking a number, for example 21. If it divides in evenly again to the function, it'll be a 0. If not, we'll have to find the other zeros. Coefficients would be 1, 3, negative 25, and positive 21. Dropping the first number down would be 1, and multiplying by 21 each time. 1 times 21 plus 3 would be 24. 21 times 24 would be 504. Negative 25 plus 504 would be 479. And multiplying again, 21 times 479 would be 10,059. Adding 21 to that would not be 0. It would be 10,080. So again, since this is not 0, that means the 21 does not work for the function. But again, we have to go through the other possible zeros to find the zeros for the function. Continuing on, picking another number to go through, I'll skip ahead and use number 3, which will end up working for this question. Again, using the same coefficients we had before, 1, 3, negative 25, and 21. Dividing down, the 1 comes down, multiplying each number this time by 3. 3 plus 3 would be 6, times 3 is 18. Negative 25 plus 18 would be negative 7, and 3 times negative 7 would be negative 21. So a 0 remainder again means 3 works for this question. If we wanted to, we can try different numbers using the 1, 6, and negative 7. A different method, once we find a factor that we have a lower degree for, we have 1, 6, and negative 7. If we plug the x's back in, the original function was x cubed. So this would be 1x squared plus 6x minus 7. Instead of trying to guess and check the zeros at work, we can actually take the polynomial function and factor this out to find the zeros. For example, if we have x squared plus 6x minus 7, we can factor this using the diamond method. Taking the last number, negative 7 and positive 6, two numbers that multiply to get negative 7 and add to get 6 would be 7 and negative 1. If you wrote this out in factored form, x plus 7 and x minus 1, since we're looking for zeros, we can set this equal to 0. And if x plus 7 equals 0, or x minus 1 equals 0, we can find the two zeros by solving the equation. X plus 7 equals 0, x would equal negative 7. And the second equation, adding 1, we'll have x equals 1. So using factoring instead of division, we can find the two zeros, which are negative 7 and 1. And the other 0 that we found using division was 3. So we can have x equals 3. Looking back at the original function, which was x to the third power, which means it has 3 zeros, we found the three numbers, negative 7, 3, and 1. So these are the 3 zeros for the function, and there's no imaginary zeros for this function. The last question for the section is g of x equals 6x to the fourth plus 22x cubed plus 11x squared minus 38x minus 40. Again, using this function, we'll find all these zeros, which again could be rational zeros using the p's and the q's, but we also could get imaginary zeros. For the p-value, the last number, we have negative 40, or just 40. And again, the factors of 40, any number that divides into 40, we could have 20, 10, 8, 5, 4, 2, and 1. And for the q values, the first coefficient 6, the factors of 6 would be 6, 3, 2, and 1. This function has many factors for p's and q's. All the possible zeros will be all the numbers divided by 6, 3, 2, and 1. So there'll be lots of numbers to go through and check for synthetic division. One answer that does work for this function would be negative 2. And again, that would be 2 over 1, but since p and q could be positive or negative, the negative 2 we'll use for this function to get it started. The coefficients, 6, 22, 11, negative 38, and negative 40. Using synthetic division from here, the 6 will come down. 6 times negative 2 will be negative 12. Adding, we'll have 10. Multiplying will be negative 20. Negative 9. 18. Negative 20. And positive 40. So again, no remainder means the negative 2 works for this function. From here, if you wanted to, you could try factor by grouping. Since we'll have x to the third power, we'll have 4 terms. This does not factor by grouping though, so we'll continue on using another 0. And again, normally you'd have to go through and just guess and check the numbers, but the number that works for this function is 4 over 3. 4 over 3 again would be from the p and q. Again, using synthetic division, dropping these 6 down. 4/3 times 6, we can do 6 divided by 3, which would be 2, times 4 would be 8. Adding straight down, we'll have 18. And 18 divided by 3 would be 6, times 4 would be 24. Adding a negative 9, that would be 15. And 15 divided by 3 would be 5, times 4 would be 20. Negative 20 and positive 20 will give us no remainder. So again, the second 0 that works will be 4 over 3. From here, once we find a couple zeros, looking back at the function, it was originally x to the 4th. When we divide out one 0, this would be x cubed. Dividing out another 0, this would be x squared. So we'll have 6x squared plus 18x plus 15. Once you find a couple zeros, that drops the function down to x squared. You can try and factor this function, or we could also use the quadratic formula. Using the quadratic formula again, we'll have negative b, which is negative 18, plus or minus the square root of b squared, which is 18 squared, minus 4 times 6 times 15. 4 times a times c. All divided by 2 times a, which is 2 times 6. Simplifying from here, we'll have negative 18 plus or minus 18 squared would be 324. And negative 4 times 6 would be negative 24. Negative 24 times 15 would be 360. All divided by 12. Simplifying again, negative 18 plus or minus the square root 324 minus 360 will be negative 36. And since we have a negative inside the square root, that's where we'll get imaginary answers, divided by 12. Equals again, negative 18 plus or minus the square root of 36 would be 6. And since it's a negative, we'll have 6i divided by 12. And last step, reducing fractions, 18, 6, and 12. We can divide each of these by 6. So we'll have negative 3 plus or minus I divided by 2. So the imaginary zeros for the original function, this is 2 imaginary zeros, negative 3 plus I divided by 2, and negative 3 minus I divided by 2. Looking back at the synthetic division we did, the other zeros were negative 2 and positive 4/3. So the total number of zeros that we should have, looking back at the original question, 6x to the 4th. Since we have x to the 4th, we'll have 4 zeros, 2 imaginary zeros, and 2 rational zeros. Title of the first section is Combining Functions. In this section, we'll combine functions by using operations in mathematics. First function we'll look at, f of x equals x squared plus 6x plus 9. And second function, g of x equals 2x plus 6. The first question we'll look at to combine functions will be f plus g of x. For this problem, f plus g will be adding the two functions f plus g. Combine like terms, we have a single x squared. Adding the x's together, 6x plus 2x would be 8x. And adding the constant numbers together, 6 plus 9 would be 15. So our final answer, after adding the functions, x squared plus 8x plus 15. Second question, and last question for the section. F divided by g of x. For this question, we can write the functions out. F is x squared plus 6x plus 9 divided by g, which is 2x plus 6. To solve this, we could use long division to divide these out, or a shortcut. Since both of these expressions factor, we can factor and then divide. For example, the numerator, x squared plus 6x plus 9, if we factor using the diamond method, two numbers that multiply to get 9 and add to get 6, those numbers would be 3 and 3. So the numerator will factor to x plus 3 and x plus 3. The denominator, 2x plus 6, we can take out a common factor of 2, and dividing by 2, we're left with x plus 3. Dividing from here, we can cancel one factor of x plus 3 with another factor of x plus 3, and we're left with our answer of x plus 3 over 2. Title of the next section is Composition of Functions. Composition of functions, we'll end up taking the composition, which is a different function, on top of the functions. First question, if f of x equals 4x and g of x equals 2x minus 1, find the new notation will be f, and a composition symbol will be an open circle, g. So this will be f composition g of x. To find f composition g of x, the new symbol again, a open circle. What we'll end up doing is taking the right side of the function, which is g, and we'll take the g function and plug it into f. For example, g, which is 2x minus 1, we'll take the expression 2x minus 1 and plug that into the variable for f of x. So for example, if we take f of x, which is 4x, but instead of x, we'll replace that with the g value, which is 2x minus 1. Simplifying this will give us the composition. And again, we'll take g, whatever that value is, plug it in for the x value of the other function, and then solve. Simplifying this, 4 times 2x would be 8x, and 4 times a negative 1 would be minus 4. So our final answer, f composition of g, is 8x minus 4. Second question, find, we'll do the opposite, which is g composition of f of x. Again, when we have the composition function, we'll go from right to left. So we'll take the f function and plug that into g. The f function again is 4x, so we'll take the 4x and plug that in to the other variable. So the g value, which is normally 2 and then x, but instead of x, we'll plug in 4x, and minus 1, which is left over from the g value. So taking the value of f, plugging that into the variable for g, then we can simplify to get our answer. 2 times 4x would be 8x, and minus 1 stays the same. So our final answer is 8x minus 1. And last question for the section. Find the composition g, composition f of 3. To solve this problem, since we have a number 3, we can either take the 3 and plug that into the f value, which will give us a number, and plug that number into the g value, which will give us our final answer. Or, since we also did the g composition of f in the previous problem, we can plug the 3 into 8x minus 1. So taking the previous function, which again is the same as g composition f, we'll plug a 3 in for the x, which will be 8 times 3 minus 1. And we'll have 8 times 3, which is 24, minus 1 gives the answer of 23. So g composition f of 3, the value is 23. Title of the last section today is Composition of Points. In this section, we'll take the composition using sets of points. In this question, f, instead of a function, f equals a set of points. The first point is 3, 8. The second point is 4, 0. The third point is 6, 3. And the last point is 7, -1. The second function, or second set of points, which is g. The first point is 0, 4. Second point is 8, 6. Third point is 3, 6. And the last point is -1, 8. Taking these sets of points, we can do the compositions. The first problem is find g composition of f. Compositions again, we'll go from right to left. So again, we'll take the f and plug that into g. When we have sets of points, we'll look at, starting with f, the first point, which is 3, 8. The 3 will be the x value and the 8's the y value. What we'll do is we'll match up the y value with a x value from g. So 3, 8, if the y value is 8, we want to find a x value of 8 in the other function, which will be the second point, and that y value is 6. So 3, 8, matching it up, goes to 8, 6, and the answer will be the x value from the f and the y value from the g. So 3, 8 goes to 8, 6, so the answer would be 3, 6. We'll take the x value from the f function, the first function, and we'll take the y value from the second function, the g function. Continuing on, we'll do that for each of the points. So the second point, which is 4, 0. Again, 4, 0, we'll look at the y value, which is 0, and we'll match that up with the x value that's also 0. So 4, 0 will match up with 0, 4, since the y value matches up with the x value, and our answer will be x, y, using the x from the f and the y from the g, which would be 4, 4. The third point, 6, 3. And again, we'll match the 3 up with the x value in the g function, which would be the third point. So 6, 3 will match up with 3, 6, matching the y value with the x value, and then the answer will be x, y, or 6, 6. And the last point, 7, -1, matching up the -1 with a x value of -1. So the y value matches with the x value. The answer will be x, y, using the other numbers, which would be 7, 8. So 4 points, and we have 4 answers. G composition of f is equal to 3, 6, 4, 4, 6, 6, and 7, 8. Second question, and last question for the section. We'll do the same process, but we'll do the opposite by finding f composition of g. Again, f composition of g means we'll start with g this time, since we go from right to left, and we'll match the g points up with the f points. So starting with the g values, the first point is 0, 4, and again we want to match the y value up with the x value in the f function, which matches up with the second point. The y value is 4 and the x value is 4, and then the answer will be the x, y, using the other two values, which would be 0, 0. Continuing on for the 4 points in the g function, 8, 6, again matching up the 6, the y value, with the x value of 6, and the answer would be 8, 3. The third function, or third point, 3, 6, matching the 6 up with a x value of 6, we'll also have 3, 3.